Hello everyone, welcome to Coding Badly. My name is Joe and I'll be your host for today. If you are new around these parts, Battlesnake is a multiplayer programming game where you write the code to control a snake in a multiplayer game of the classic game Snake. And Coding Badly is a show where we show you how not to play Battlesnake in the most creative ways that we can come up with. And yet again, I am alone. My co-host Kevin is still off in the wilderness doing important things. And so we are continuing in this very spooky of months, doing our Building Battlesnake in Strange Languages. And this time, that is with the imitable Factor. Hi, he also was fine. You've rescued me from the eels. If you didn't know, I have declared October as Eel Fact Month because for some reason the stars have aligned so that lots of people, myself included, are learning about eels this month. So I highly encourage you to go and learn about the important eel, particularly those of the family Anguillidae, the freshwater eels, of which there are 19 species, most of which are endangered. We're doing a spooky thing today, as you can tell from my dramatic lighting situation. This is tea served in a mug from a cafe that gave me food poisoning. It's truly a horror show here. And so welcome to spooky season. Welcome to Coding Spookily. Let us get on with the code. That's entirely the wrong layout. This one? This one. This one. Cool. So, we're back. We're back to do Factor. For those of you who didn't tune in last time and missed the first time, what is Factor, I hear you ask? Well, let me show you some Factor. Here is some Factor. Factor is a concatenative stack-based programming language. The most important things to know about, I guess, the syntax of the language itself is that it is postfix notation and it is, as I said, stack-based. What does that mean? Well, if you observe the window on the bottom right, that is the Factor listener. That's kind of our little REPL, our little live programming environment. Right now, we're in Scratchpad. That's kind of like the prompt, like your terminal prompt. And I can pop something onto the stack, like hello world. So that's just a string, press enter. You see there, it displays the stack. We're in the stack. It's on the stack. I can then pop it off the stack and print it. Look at that, hello world, and now my stack is empty. I can do that all in one line if I wanted to. This is the postfix notation. Observe the string hello world being given to the function, or in Factor parlance, the word print. And there you go, hello world. Once things are on the stack, I can do various things. I can manipulate them. I can duplicate the contents of the stack. I can swap contents on the stack. And words can pull things off the stack. For example, if I were to do a plus right now, it's going to grab 2 and 3 from the top of the stack, and it's going to put 5 on the stack. So it's really fun. It's I really enjoy the code that results from this paradigm. I find that it reads very naturally. It's literally left to right, so it's very intuitive to read the code. Knowing that the stack as a place where your state is kept as opposed to a series of variables, it's again like a very simple mental model. It's very easy to keep the program state in your head as you go. There are variables, there's different mechanisms for variables, and the web framework, the HTTP server does make heavy use of variables for lots of the parts of the HTTP request lifecycle, so we will be seeing variables today. But in general, the stack is the place to be. We want to live on the stack, we like the stack. The language encourages us to do stack things. And so last time, we got set up with everything we needed to start accepting some requests. So we're using the Factor web framework, which is called Furnace. I didn't finish. Let me actually talk about that briefly. So we've got the listener. The listener is the programming. It's the compiler. It's the whole shebang. It's the development environment. It's this thing as well as a load of other stuff. So like for example, I can do I can inspect objects and get this cool little inspector. I can click help and this opens up, and this is the documentation, and all of the languages are kept in a monorepo, and this has access to all of them. So I can go and look up Furnace, the web framework, and find the vocabulary, the library for furnace. And it's, as you see here, it says I must load this to use it. So let's do that and load furnace so we can see some docs. And yeah, it's just all here. It's been a very pleasant development environment. It was very easy to get started with Factor because all the docs are here, all the examples are built into the language. It's just been a lovely time. It's just been a lovely time, chat. So let's load up Snake. Let's load up Battlesnake. So I'm gonna import our Snake code, and let's first of all make sure that things are working. Do we get some Snake info? We do. I have changed something a little bit since last time. See if we get that. We don't get that. We don't get that. So I think I probably need to do a use snake.move handler. And we still don't get that. Am I using, is that the wrong one? Is it just move handler? Might just be move handler. There we go. Perfect. Cool. That will do that. Okay, so let's run through the code as it currently stands. This is a bunch of imports. Oh, actually, let me quickly set some stuff up. I need to put auto use on. There we go. This is our imports. This is all the stuff we are importing and using. This lets Factor know that everything we're defining in this file belongs to the vocabulary snake. This tuple is a class, essentially. So this is for the web server. This is just a variable we are setting. We are setting the development environment. So development ? Is a variable that tracks whether we're in a development environment or not. And in Factor, booleans are T and F, true and false. So we're taking true, we're taking the variable and we're setting that variable to true to tell Factor that we are in a development environment, and that enables logging in the HTTP server, and it also enables live reloads in the HTTP server, which is very nice. This is just a big blob of JSON for the info endpoint on Battlesnake. So in Battlesnake, one of the endpoints that gets hit by the Battlesnake server is the info endpoint, which gets your snake info. So I've constructed a JSON blob for that and stored it in snake info. You'll see here there's this colon at the start of the line. For those of you who didn't tune into last stream, and hey Praduma, thanks for joining us. Those of you who didn't tune into last stream, this is a word definition. So a word is a function, essentially. It's just what Factor calls functions. You start defining a word with a colon, followed by the name of the word, and then this is a stack effect declaration, so it's like a type signature. They always have -- in the middle, and on the left of the -- is what it's consuming from the stack, and on the right is what it's putting onto the stack. So this function doesn't take any data, it doesn't take anything off the stack, but it does produce some JSON which it puts on the stack. Important to note, this is just a name. This is just a string. It's not quite a string, but like this is just an identifier. It's not actually, there's not a type called JSON. It's not type checking JSON. You can put whatever you want on either side of that. It's basically checking for like parity more than anything. It's checking that you're taking the right amount of things on the left and you're putting out the right amount of things on the right. What those things are named doesn't matter. But this is putting out JSON, so I've named that JSON. So as I'm reading it, I know what I'm outputting because this creates a JSON blob. One of the really cool things about Factor is it has really strong naming conventions for words. So, for example, there's really strong naming conventions around things like constructors, around getters and setters, readers and writers. So when you have a angle bracket on the right hand side of a word name, it means it is a writer. I can't remember which way around they are. In this case, JSON angle bracket, right angle bracket means it takes a string and produces JSON. Whereas if I had JSON left angle bracket, it takes JSON and produces a string. And this is a naming convention that's pretty well followed through everything I've seen so far. So you know that if you rock up to any particular type, any particular class, you know how to get and set fields and properties, you know how to convert stuff. You can see that here. So here's another one. This is to get, there's a property called display within this object, and we can set that property with 2 left angle brackets. And as with everything in Factor, it is nicely documented in the inbuilt help thing, so we can see our naming conventions down here. So you can see 2 left angle brackets is a setter. Very nice. So I enjoy that a lot. Some other things. So you'll see these function names begin with have angle brackets around them. That's because they're constructors. There's square brackets. This is a quotation. So if I go back to the listener in the bottom right, so I can do so 1, 2 plus will produce 3, right? So it's taking the 1, putting on the stack, taking the 2, putting on the stack, and then adding them together. If I were to do square bracket 1, 2 plus, you'll observe I don't get a 3 on the stack. I instead get that whole expression. Quotations, that's what the square brackets are called, are essentially anonymous functions. So that has defined a function containing 1, 2 plus, and it's popped it on the stack, but it hasn't executed it, so I can then execute it. So this is really useful for passing functions to other functions. So if you have a function, for example, this is how if statements are implemented. So an if statement takes a Boolean expression, so I'll give it true, and then it takes a quotation. It takes a Boolean expression, and then it takes a quotation, and another quotation, and then you feed it to the function if. So what this says is like, if this is true, if the Boolean expression is true, execute the first quotation, else execute the second quotation. So I'll do 1, 2 plus, and if it's false, I'll do 2, 3 plus. And because t means true, this will evaluate to 3. But if I were to do that again with an f, or accidentally hit enter too early, there you go. You'll see now it's 7 because it's 3, 4 plus. So when you see these square brackets, that is essentially me constructing an anonymous function because it's getting passed into something, or in this case, it's getting set as a property on something. So very similar to in JavaScript, when you have a property and you set that property equal to a function, that's kind of what this does. So in this case, there's a display property, and we're setting it equal to the contents, to this function, basically. So that's a lot of what's going on here. This is just the basic this is just the basic HTTP server. Furnace, the HTTP server, works in a little bit of a different way to other web servers we've covered on the show. Particularly things like Express or other web frameworks we've covered on the show, particularly Express. It's kind of motivated by the form submission lifecycle. So it's all based around these things called actions, and actions have, here we go. Actions have different properties that get called at different points in the HTTP lifecycle. So for example, you will see display is a quotation, so an anonymous function called when a get request is received. We have validate, which is called when a post request is first received, and then submit, which is called in the next step of the post request. So if we want to handle get and post requests, we need to build an action and then set these properties for the correct thing. So that's what we're doing. So we've got the info action. So this is an action that I want to call when Battlesnake calls the info endpoint on my Battlesnake, on my web server. So I'm constructing an action, and page action is a constructor for Furnace actions, which use the Factor templating language. I'm not actually using the templating language, but it also means you don't have to manually specify the response type. So I'm doing page actions. So I'm constructing a new action, and then in that in the quotation, I'm taking this snake info JSON blob, turning it into JSON response content, and then I'm setting this whole quotation to be on display. So that means that the display property is called whenever a GET request is received. So when a GET request is received, factor will go into the to this endpoint. Factor will go into this action we've constructed. It will look in the display property. It will find this blob of code and it will run it, right? And so the move action, this is the move endpoint on our Battlesnake, works very similarly. We have a quotation here. Ignore the outer bit. There's some logging going on here. We care about this bit. We have a quotation that's being given to submit, and submit is called whenever we get a post request, because this is the request to us that contains the game state. And so in here, this is a quotation that does a couple of things. So it gets that post data. So Fernit, well, the HTTP server will store the request on a variable called request. So we're getting that data, and then in the resulting data is a object which has a post data property, and then in the post data property we go and get the data. So as mentioned before, angle brackets, these are getters, so we're getting this data. And then we do something that is a little bit complicated looking, which is this is logging. So the backward slash, whichever direction slash that is, that slash, what does that slash mean? It means like put a word on the stack, but like I couldn't, there we go. Reads the next word from the input and appends a wrapper holding the word to the parse tree. So like it pushes it onto the stack essentially. So like if I do that, there we go. Now plus is on the stack. So in like, I guess it's a little bit like putting it in a quotation, but for a single word. So log, this is for, so all this is for my logging. So whenever we get, this is logging the request body essentially. And so log message is a word that takes it takes a string that you want to log. It takes a word, so a function that's kind of that you want to say is responsible for producing this log, and it takes a log level. So how this will work is all of this stuff will produce the post body that's coming with our request. This bit will move action will get plopped onto the stack. So this is the word that we're saying produced this. Notice is the log level that we're doing, and then it will get given to log message. So essentially this whole line logs the request that we received from Battlesnake, and I can show you that actually. Let me quickly pop open the log. Here it is. Here's the log. So you can see it produces this. So you can see the timestamp. You can see it's a notice level log. It's produced by a move action, and then this is the post body. Cool. So after that, we are handling the move. Handle move right now is just set to contain a left move. So it just has a JSON blob containing move left, which is the response we need to give to the Battlesnake server, and it gives that over to, it turns that into JSON response content. This with logging and coding badly, this is to make sure that this endpoint logs, but otherwise that's not important. But what it is important is that this whole quotation, this whole anonymous function, then gets set to the submit property, which, as we spoke about earlier, the submit property is called during part of the post request lifecycle. This is the part where the server wants to return a response to that post request. We then, this is the bit that looks quite a lot like a routing framework, like Express or Sinatra or Flask. We take those actions we've defined. We say what we take the word. So the actual action, the words defining those actions, we give them a root. So this one, like a URL. So info is just on our root, on our empty URL, and then the move action is called a move. We feed those into add responder to construct responders from them, I guess. And then this produces what's called a dispatcher. And then that dispatcher we give to the HTTP server. And ta-da! we're able to receive requests. So let's run the thing. Let's do the business. I'll open up a new local host and close that one. Boom. It works. Let's check it works with a game. I need to start my ngrok. Ngrok is running. Good. Let's make a game. Hello? Snake? Why isn't my Battlesnake here? There we go. It was having problems. Create game. Custom game. Factor Snake. I think I've added that. Yes. And this should do nothing but go left. There we go. It goes left. Excellent. So that's where we left last stream. That is where we left the last stream. And so today we're going to process moves. That's right, everyone. It is time for another episode of Coding Badly. Write the basic logic to avoid the walls and avoid your own snake. But this time in a weird programming language. So let us go ahead and do that. I do see in the users list... I do see some recognizable names in the users list. Some kind folks from the Factor community did tune in last time and taught me a bunch of awesome stuff and answered my questions, and I believe those same folks are here. So hi, thank you for joining. I'm sure I will do something else very silly this time as well. First thing that may be silly, I'm guessing at how things are structured. This is how I've done it. So I've got a new directory called move handler, and in that I've put move handler. So this is where we're going to be doing the move handling. And as I mentioned, right now we're just returning left. So for that, I have this word called sample move that just constructs a JSON object for a left move. And I'm just handle move that we called in the move endpoint. Literally just does that. So we need to do things in here. The first thing that means is that we need to give this a game state, which we don't currently do. So we need to give it a game state. So you'll recall that I said that this blob here builds gets the post data, the JSON blob, which we're given to our logging. So by the end of that blob of code, that game data, the game state is on the stack, but then we consume it off the stack when we give it to log message. So I believe what I need to do at this point is a dupe. So dupe duplicates the item on the top of the stack, and so that will make a duplicate of our post body, and the first one will get consumed by log message, and then the second one will be available for handle move. I believe that is what we need to do. We'll see. We'll see how that goes. So this now takes a game state, and it's is that game state a string? I believe it probably is a string. So I might want to do a JSON reader to it. Log message takes a string. Yes, it's probably a string. So I might want to do that to turn it into JSON. I think I want it in JSON, because if it's in JSON, so for example, if I were to call snake info here, you'll see, I don't know how readable, so I don't know how readable this is. If anything looks like really small, let me know. What I can probably do is this might be better. So you'll see we've got this thing here with lots of curly braces and a H. This is a hash table. Oh, sorry, let's open the wrong one. Inspector. There we go. This is a hash table. And that's so, that's how it's representing the JSON. We've got our JSON, we've got our properties as the keys, and then we've got the values. So I probably do want it that way, not as a string. So I am going to want to throw one of those in it. And that should give me, over in move handler, that should give me a JSON game state here. And then I'm also returning JSON. This is current return JSON. So let's just check we are actually doing that just by like, I don't know, just by putting it out. Wait, is that how that works? I think that's how it works. Actually not have an input on anything. This is a really... Is that really the first time I've done this? I assume so. So this won't appease Battlesnake. But it'll let us know if we are actually getting the JSON we expect to be getting. We'll be able to see it in our logging. So what I don't know at this point, as I said, we are running this in development mode, which means the HTTP server should auto restart, but I haven't completely gotten a handle on which changes capture that. So the big one that has been tripping me up is adding these endpoints as responders happens before the HTTP server starts running. What happens outside the HTTP server? As you can see, it happens here, and they get set in a global variable called main responder. So making changes to this dispatcher, when I make changes to that dispatcher, I have to restart, or if I make changes to this word, I have to restart the listener. But I think we'll get away. I believe I don't have to do that for this part. And we'll change the snake's color to green just to verify that we are getting changes. We'll give that a refresh. Yes, okay, so this is why I pulled a funny face, which is I actually realized I don't just know how to return the stack object that this is consuming. So I guess actually, so it's taking game state. Do I just want... I actually just don't know how to do that. Oh, it's automatically on the stack. Okay. So it's automatically on the stack. So like, if I just want this word to do nothing. So essentially like this word takes the thing off the stack and puts it back on the stack. Do I literally just leave it empty? I could test this. What am I doing? Let's test this. And hi, Annika. Thank you for joining us again. Yes. Perfect. Awesome. Rad. Thank you, Annika. As ever, you rock. Okay. So, let's see if that does the thing that I think it should do. So we shouldn't see the Battlesnake go left here. If we do, that's an indication it does go left. This might be an indication that we do need to restart the server. Does it go green? It has gone green. So that endpoint's been picked up, but it looks like the handle move has probably not been picked up. Oh, I've accidentally gone to the live stream. There we go. Let's click on that. Great game. Yeah, okay. Bye, listener. Annika, I did not actually... I did not end up clearing out my factor image. So I am still going to have the slightly silly situation we had last time. Okay, that's fine. That's probably because I need to do that first in the game. Already using Snake, and then I should just be able to do run Battlesnake in Fred. Okay, just make sure that's working. Yep, great rematch. Why are you still going left? Let's have a look at our logs. We are still returning. Did I not save this file? We are still returning a sample move. Make sure that server's actually died. Good, that server has actually died. Oh, this was the silly situation. Yes, because I need to reload Snake because I accidentally saved it in my image. And then I'm not okay. My image is a mess. How do I load that vocabulary? Okay, let's cut that. What are you complaining about here? Now it's complaining that move handler doesn't exist. What? Why do you think move handler doesn't exist? Did I need to call that snake.movehandler? When I had that before, it was complaining about it. Okay. I'm very confused about what's happening. I don't know. I don't know what went wrong there. But we're okay now. Okay, so that's reloaded. Let's make sure move handler is definitely reloaded. And then it's gonna be such a pain every time I need to restart. Gotcha. Thank you, Annika. So this now needs to be snake.movehandler, and then if I reload, we should be good. Thank you very much. See, now sample move can't. That one. There we go. So will that continue to work now? Yes, cool. Okay, we're there. Run Battlesnake in Fred. Why? We are running very much. Okay, we go up. Perfect. We go up, which means we've broken things. Which hopefully means we do... I am not logging. Okay, so we're not logging because I need to define a log notice thing. So that's going to be handle, move, notice, add output, logging. Now to go through that whole dance again and work out what was going on. Okay, so close the windows. Restart factor. To the left. Okay. Reload all. Perfect. Run. This is not. Run Battlesnake in thread. That will error. Use the snake vocabulary. Use the thread's vocabulary. We're up and running. Perfect. Give that another hit. We're going up. We open the logs. Hey, there we go. Perfect. Okay, we got there. We worked out our restart cycle. And you can see that our handle move is returning the hash table of all of the game data. Bish bash bosh, job's a good un. All right. Why was it returning it as a hash table? Oh, our sample move was as well. Okay, cool. That's good. That's fine. Perfect. So we have our request body right where we want it to be. So what are the trails of things that we always need to do? We need to get our snakes snake head X, Y. We need to get all surrounding squares. We need to eliminate square containing first next segment. We need to check X against 0 and board width. We need to check Y against 0 and board height. Perfect. That is the things we need to do. And Factor encourages you to do things in small functions, small words. So that is what we're going to do. So let's start by getting head. And getting head will take the game state. No, it will take... Yes, it will take the game state. Now, how do I want to do this? So I'm trying to think like how I want to build these functions. And this is where I don't know what like the... Why did you just yell at me, Hugh? What's up? Oh! Oops. Do I want to have this work like a pipeline kind of situation where each of these words puts a game state back on the stack to be consumed, or do I want to have handle move deal with making sure that game state is kept on the stack? I don't know what the correct way to do it is, but for now I'm going to keep it simple. I'm just going to have this return an X and a Y coordinate. We'll start with that. I don't know if that's going to feel nice. So we get a game state, and from that game state, we are going to want to get some properties. And for that, I'm going to have to refer to the Battlesnake documentation. Let's bring you over. So let's actually have a quick look at that object. So H is going to have a game. Perfect. So we're going to get game. Oh, I can. Yeah, sorry. I actually want you. We're going to get you, and then you is a Battlesnake object. And then we're going to dupe you, and then do No, sorry, we're going to do head, and then dupe head, and then do X, Y. So, how am I going to test if that works? Am I going to have to grab a game state? Let's grab the game state out of the logs and save it as a... Oh god, I don't want to have to escape all of this. How am I going to make this usable inside the game for testing purposes? How am I going to test this? I need a sample game state to test this with, because I don't really want to be restarting the whole web server every time while I'm building these functions. I just want to throw like a whole game state object somewhere. Sample. Let's put it here. There we go. So I guess I can read this file. Guess we're going to learn how to read files. Okay, let's see if this complains first of all. It does. Is that not how the hash table accessors work? Okay, to hash tables we go. Hash table keys. Oh, nope, it's not what I want. Maybe it was. Hash tables. Hash table syntax. So creating a hash table. I remember seeing this before because I've done this. It's the associative, it's the assocs, and then it is at, isn't it? I did this when I was messing with the threads. Yes, it's at that I want. So it will be I guess this is a string, so it'll be u at, and then head at, and then dupe, and then x at, y at. Let's try that. No. Oh, no, that's fine. Use the assocs word. Use the kernel. Oh, I didn't make those strings. Perfect. Grab this. Hey, Being, how you doing? Great. Okay. That's hideous. Let's break this over some lines. U at, head at, dupe, x, blah, blah, blah. And so that should do the business. Now, let's find out how to read a file. I guess it's going to be IO. Input and output. Reading and writing files. File contents. Let's give this a go in the listener. Let's experiment in the listener. So use IO files. Already using it, great. And an encoding descriptor. Ooh, that I don't know what that is. Encoding descriptor. Got an example? Do we have an example? IO encodings. Just UTF-16, I guess? Let's do Word. Okay. The path, there was a way. Let's go back to the factor handbook. Your first program, creating a vocabulary, work, resource, path. Let's pop that on the stack. There's our path. Actually, I do want that off because I want... Hi, being 707. So we are playing Battlesnake. Battlesnake is a multiplayer programming game where you write the logic to control a multiplayer game of Snake. So you have, the classic game of Snake, and you write code that controls the snake, and that code lives in a web application, so in a web server, so it accepts HTTP responses from the Battlesnake game, and then you return the move that you want to make for that turn. So you can see a little game here of some snakes working around. So we are writing the code for a Battlesnake. The catch is that we're doing it in a language called Factor, which is a really cool language, but not one I'm overly familiar with. It is a stack-based concatenative language. It's really interesting. And so yeah, today we're just experimenting with writing Battlesnakes in fun languages. And so we're using Factor. It's our second stream on using Factor to write a Battlesnake. Let me know if you have any further questions. So if I do... How do I concatenate strings? That's a good question. Just concat. Not that. Strings. It is a sequence. Okay, let's have a look at that error message again. Maybe I didn't pay attention. The error message, generic word limit not to find a method of the fixed num class. No, but I'm cool, that means. So it is a sequence, which was what concat worked on. Oh, it's only taken one. Being 707 said this seems cool, so we can use any language this right, like Golang, Java, or Python. You absolutely can, as long as you can receive HTTP requests and return a JSON object as a response. You can use any language you want. So I'll throw up the website. Let's go look at the current season. So Battlesnake has competitive seasons as well as like regular game modes. But from here, we'll be able to see the. Can I not see the current leaderboard? Is leaderboard not up? That will be in full league leaderboard. So if I go and look at the current leaderboard, you'll see these are some of the snakes currently playing in the full league. You'll see we've got a snake in Rust, a snake in C++, TypeScript, Java, Go, and also Python, interestingly. Yeah, loads of weird stuff. We here on this particular Twitch stream have gone out of our way to make snakes in really silly languages. So we've done Blockly before. We made a snake in Blockly. Blockly is a toolkit for building graphical like Scratch block like interfaces, most used for like kids programming. We built a snake in Blockly just because we could. We had a well-known Battlesnake player, Fable, come and build a snake in pure Bash script, just entirely Bash script, including the web server, entirely just in Bash. here. So yeah, literally anything. As long as you can deal with the HTTP requests, as long as that language has a web framework or a HTTP library like Factor does, you can make it work. You can, if you want to use something really weird that doesn't have a HTTP library, you can always use a intermediate language as well. Okay, this is like a lot of faffing around for me, just like taking that and editing it. That's not what I wanted to do. Oh my god. Why can't I copy, paste? Thank you. Snake, sample, what did I call it? Sample, did I call it sample state.json? Okay, we have a path. So io.files, yes. And then I wanted file reader. Files, reading, writing files. File contents. We have a path. And then UTF-16 doesn't look like an encoding. That, great. And so now if I do file contents, missing bomb. Missing bomb. What is a bomb? And why are we missing it? What is a bomb, and why are we missing the bomb? Does this have error messages in it? Yes, missing bomb. It's in encodings. Okay. Is UTF... I just guessed UTF-16, and evidently I guessed incorrectly. What's the encoding for a JSON file? UTF-8. Oops. Yeah, right. Being gets it. Okay, so being this language Factor. One of the things I like most about it, like the language is really cool, and I've really enjoyed the language. But like this tool set, this thing here is called the listener, and it has built-in this built-in documentation viewer, and so all of the libraries in Factor are in a mono repo. So when you get Factor, you get the listener and you get all of the libraries as well, so you don't have to like go download anything. But then like all of the documentation for the libraries that that you have in your Factor distribution and your Factor image are just right there in the development tools. So like it's you can just self-teach to an amazing degree and just poke around and have, and just make stuff without, going over to Google and trawling through terrible dev2 blogs and stuff. It is truly, truly delightful. So we don't want UTF-16, we want UTF-8. So now let's try. Hey, we did it. Okay. So now we have JSON in string. So now I want to give. Is my snakehead function? That will error. No word snakehead found. Okay. I want to abort that, but I want to reload. Great. So now I want to do JSON that snakehead. Well, actually, let's just do JSON that first. Make sure we do get JSON onto the stack. Use JSON reader. We do get JSON onto the stack, and now if I do snakehead, we have an error. Generic word env does not define a method for the fixed num class. Okay. Let's back this up. Let's see if we can get you first of all. Oops, I've got errors. because I'm only returning one thing. There we go. Perfect. Snake head. Okay, we're still getting this problem. So we have this hash table. So if I were to do U, okay, let's put U on the stack, swap them at. They're the wrong way round. They're the wrong way round. That is the problem. We're working with stacks, chat. God, this is so satisfying. Like, I know that for the last, like, 30 minutes, I've just sat here, done nothing. Like, I've done nothing. This whole stream has been me doing absolutely nothing. But, like, this is such a satisfying environment. I just feel like I'm having the most fun. Like, it is the least frustrating programming experience I think I've ever had. Like, it's so nice. It just makes you feel so good. We have a U, and so now I can do head swap at X and Y. X swap at 4. Okay, we know how to do it. So let's clear that up. Let's load test file. JSON. Let's make a function to do this. So that was our path. Let's just go up and grab that. Copy. No, don't want to copy object. I want to copy the string. Oh no, I don't know how to do that. Can I copy it from here? Oh my god. Copy. So there's our string. And then, oops. Then we have UTF-8, and that we're going to need to add IO encodings UTF-8. And then we do file contents, and that's going to need was it IO files? IO files, yep. Okay, so let's try that. Beautiful. And then let's do a JSON on that. That's probably can complain. No, funnily enough, not. Drop load test file. Yeah, perfect. Okay, so let's now do test snakehead, and we want to get an X and a Y out of this. Okay. Right, so let's run through that again. So we get U. So snakehead is being given the JSON blob, and then we need to put U on. So it's JSON blobs on the stack. We put U on the stack. We swap. Then we do at. Then we put head on the stack. We swap and we do at. Then we put X on the. Then we dupe. We need 2 heads, and then we put X on the stack. Then we're going to have a problem. U swap at head swap at dupe. So if I now do X swap at, I have 4, and now I need to get the thing previous. And this is where we're going to need to look up some new swap words. Because I think there's probably a better way to do this. New swap shuffle words, rather. A better way to do this than I'm about to do. There are additional complex shuffling words whose use not recommended. Okay. Oh, I guess at this point I should just consume that word. I might just, I might just, I might be doing this completely asked about face, but this is a shuffle word, rearranging the top of the data stack as indicated by the word stack effect. So we take an X, Y, and we get the X. Yes, I want an over. Amazing. So now I do, so swap at X, X swap at, and then I do Y. That didn't do it at all. I want that thing. I want the thing that's free down. I guess I won't pick. But I also want to remove it from the stack. So this does kind of do it. This is what we want. I guess I can finish it with a... I mean, like, if I want to be really stupid, like, I could swap, and then that swaps the Y and the H, and then I can Y, and then I can swap, and then I can at. So, hang on. Swap, Y, swap, at 4 and 9, and then we're at where we want to be. But like, there's no way that's idiomatic, right? Like, this is where we get to like, I've like done enough factor to vaguely know the shape of, well, like, to vaguely know how to achieve things, but don't yet know how to achieve things well. maybe I shouldn't have like one function to return an X and a Y, and should break this up into like words to get the X and words to get the Y. But hey, we've done this now. Let's make sure this works. So test snake head 4 and 9. Okay, it works, everyone. Happy days. Annika, are you still here? Annika, how am I? Can you rate the snakehead function for idiomatic factor on a scale of like, what are you doing to, I don't know, looks fine to me. Every time I do this stream, I half expect to open the factor Discord and like find I'm being denounced for crimes. But so far, that's not been the case. I would love to know a better way, Annika. Nothing would delight me more. That would be my dream come true. Being 707, what brought you to the stream today? Did you know about Battlesnake before tuning in, or did you find us randomly on Twitch or Twitter? Like, how did you wind up here? I'd love to know how you discovered this particular stream. You of what is of? Looks up the value associated with a key. Okay. Outputs value F. Wait. U of. How is this different? Oh, I see. Wait, do I see? It puts the whole, right, I see. So, okay, hang on. So like, if I now load the test file again and then do U swap at, right, okay. So it's literally just the same, it's the same thing, but the inputs are the other way around, right? That's key, takes a key in ASOC. This takes an ASOC and a key. Amazing. That's incredible. Thank you. And then the quoting, let me put this on the screen actually. Sorry, here you go. Here's Annika's better way. So So first up, we've got the of. The of is at, but with the inputs the other way around. Of course, that exists. That makes a lot of sense. But then the quoting I really like, and so I guess this by. Oh, of is swap at. That's really funny. This is another really cool thing I like about the factor docs. Is like the definitions are all just like their definition. It is literally swap at. That's really funny. Oh, that's delightful. Okay, so by, I'm guessing that's taking two quotes and calling them. Applies P to X and applies Q to X. Incredible. Incredible. That's delightful. Okay, let's whack this in. So we're doing U of head. And also, look, this is what I meant when I said it's very intuitive to read, right? U of head of, and then this is the first of our, that's a quote. And then we do our second quote. Y. I should have left my previous garbage code in there as a comparison. I will put it back in there. Oops. So I had U at swap, head at swap, dupe. Yeah, head Y. Oh, wait. Swap at head. Swap at dupe. Then we do Y. Swap at. Then we had like swap. Yeah, anyway. I'll leave it there. Just a hint that my stupid way was like this. Oh, nice. Very cool. Welcome to Battlesnake Land from Twilio Quest Land. Very glad the web of weird games about programming keeps on growing. And yes, thank you for finding that bug. I think we fixed that bug. I think we fixed the bug. You ended up leading us on like a fun trail of finding collision bugs in a load of content. It turns out there was actually quite a few places you could slip through the laser barrier. So thank you for identifying that. Okay, let's give this a refresh. Can't nest definitions. What? Oh, I've accidentally knocked off the thing. Test snake head. Huzzah! Oh, we still end up with. Oh, I didn't clear the stack, that's why. So I'm assuming then that by is defined in terms of doing a bunch of dupes as well. A dip? What is it? What is a dip? That's very cool. Removes X from the data stack, calls its quotation, and restores X on top of the data stack. But then how does where does the result of the quotation go? Is that what keep does? Calls the quotation with a value on the stack, restoring the value. I don't understand that definition at all. So it takes, by takes an X, a P, and a Q. We dip keep. So we have XPQ on the stack. So we put keep on the stack. And then we dip. And dip will take a quote and keep. So it will. X will come on top of the stack and keep will get run. Not going to think too hard about that. But by is cool. Stack of theta X and the following two lines are equivalent. PQ by dupe PQ. Yes, this is what I was expecting. Cool. Very cool. Okay, so that's our head. And Annika has once again taught us a thing. So one of the things I really like about that, about at at being defined in terms of, of being defined in terms of at, is it remind me of a thing I always used to really like about Haskell, the Haskell standard library, which was like lots of things in the standard library would like just defined in terms of other really simple things in standard library and very like single line definitions. And so it has that same kind of like property. All right, Being, thanks for being here. Sleep well. Thank you for tuning in, and good to see you in chat. Okay, so we have our snake head. Let's go about getting all the surrounding squares. So what do I need to actually do here? I mean, do I even need that function? I don't want get left, I want to check left. That's what I'm doing. So I'm gonna want a no, this is again silly. What I should do, okay, how this function should take current head position, build an array of surrounding squares, and then filter on safety, filter on safe square, and then a safe square is one not containing a body, segment, or out of bounds. So then I need a function which checks for body segments and one that checks for bounds. There we go. Okay, so let's check for bounds. So we'll take an x and a y. That'll be the square that we're checking, and we'll return true or false for safety. How we can do? I haven't even done comparisons yet. I guess we just have the normal comparison operators, right? So yes, we do have the normal comparison operators. But yeah, I need to check for bounds, and so this is where I have this x and y. So I want kind of like a similar. I'm guessing there are like, are there other versions? Are there like more things of by? Yes, there is. Try, cleave. So try is as big as it gets. What is 2 by? 3. What does this do? Oh, with multiple effects. Okay. And then what is cleave? Applies each quotation to the object in turn. So it takes a sequence of quotations and then applies it to an object. So I could do like a 2 cleave. I think I want a 2 cleave here. And then I want to build an array of quotations. So like, oh, I don't know if I feel good about this. So I want to do like, so I'm gonna have 2 cleave, and I'm gonna build an array of, can't remember how to build arrays. Array. Exactly like I'm doing. So we'll have an array. What's the separator in an array? Okay. So we just have an array of quotations. So, oh no, I don't want to cleave. I want to. Yes, I do want to cleave. Is there an and? Yes. That's not what I want. How do I Boolean oh, it's just and, okay. Okay, so sorry, this is the stream. So I've got this array of quotations that we're building, and the way I'm thinking about this, so toCleave takes the two things in our stack and applies them to each of these quotations. So we're going to have 4 quotations here, and each quotation is a bound that we're checking, right? So we want to check that our x isn't lower than 0, our y is not lower than 0, and our x isn't higher than board width, and our y isn't lower than board width. Which actually, this is incorrect then. This needs to have... I guess I'd just make a function for getting... I'll make a function for board width. So, like, we'll have... board width. And board height. I'm not really thinking about the efficiency of stuff. I probably should be, but right now I'm not fussed. And then this will be very similar to our snake head, which will be let me get the... So it should be board, the board object. So it'll be board of height, sorry, board of width of, great, and then this will be board of height of, so then check bounds, we're going to have, oh, thank you, Andrew. I've got a new achievement. I'm a community creator. I get a new Hydra tail. Where do I see my achievements? Andrew, where do I see my achievements? Oh, there. Yeah. Yeah. Thanks, Andrew. I mean, it seems a little bit, you know, I'm like meant to be here. Okay. So check. Oh yeah, but yeah, see, this is why I didn't think I wanted to cleave. This is why I didn't think I wanted to cleave. Is it just like... No, that's got to be fine. Do I actually want 2 successive cleaves? Is that what I want? Oh, it doesn't output anything. Oh, that's not correct then. think I can just do this with a by. I think I'm being really silly because like what I actually want to do is like I can do, it's gonna be 2 by, isn't it? Applies P to the 2 input values and applies Q to the 2 input values. I want it more like the other way around. I want this also outputs nothing. Oh, because the quotation they're outputting things. Oh, yeah, okay. Oh, I'm really in the think tank with this one, pals. Right, let's just go back to what we had and we'll describe it and then we'll work from there. Okay, right, so check X less than 0, check Y less than 0, check X greater than board width, check Y greater than board width. Right, so that's just going to be 0 less, 0 less, and this is immediately making it clear like why this isn't going to work. Can I do board width 1 minus, yeah, board height 1 minus, okay. So the problem with using cleave for this is I want to apply X to this, Y to this, thing to this. So actually what I want to do instead is use AND. But then how does AND work in this case? Oh, Boolean expressions and a stack-based thing are messing me up. Okay, so let's say we've got like a 1 and a 2. I want to do 0 less. That goes back on the stack. Yeah, so I can buy this, right? So 1 and 2, and so then we do 0 less, 0 less, and then we buy that, and then we have false, false. But then I need to do that again. Oh, it didn't do it to both. Of course, I need to do 2 by. This is, yeah, okay. This is where I'm getting confused. So I need to do 2 by here, but then I need to throw away. I need to throw away the one I'm not using. So like, I need to do something like 2 by, where this one I do drop, so I get rid of the Y, and then this one I do swap drop, so I get rid of the X. There we go. But then I've got 4 of these, so I want to be using 2 cleave. I've done it. I understand, chat. Okay. Swap drop. Drop. Swap drop. And then this. Oh! Let's go through the errors. Here we go. F3. What errors we got? Stack effect declaration is wrong in check bounds. We're getting an XX. That's because I then needed to filter. What's it called? Filter. Sequence quotation. If you update your code, do you refactor it, or do you factor, or do you you refactor the factor. The factor Discord seems to make lots of jokes about refactoring factor, and that being why factor is that, and like despite it being called factor, it's hard to refactor, was a joke I think I had seen. So that gives us a sequence. No, it doesn't give us a sequence. What does that give us? Does it give us a stack of things? We're just getting 2 things on the stack. I don't want 2 things on the stack. I want something I can then filter. So I end up with... I'm ending up with... Why am I ending up with just 2 outputs, actually? Also, why does it think the inputs are the same? I'm gonna guess it's not being called yet. So this will apply each quotation in turn. So it should result in 4 things, not... Do I just get 4 things on the stack? Then we'll have to test this. Okay, let's do 1, 2, and then just do a bunch of these to see what happens. The generic name is just X. Cool. I thought it would have at least differentiated. I thought it would have changed the name to differentiate that they're not the same thing, but I guess that doesn't matter. One, 2. Okay. Oh, I didn't make that into an array. Yeah, that'll be why. Ugh. Oh. Yes. Thank you, Annika. You are correct. Also, I'm not giving them a game state. I'm using those completely incorrectly. The board width and board height, I'm just like not even remotely doing right. I'm just oh god. VJ asks, is this a functional language? Kinda. It has lots of... It has a lot of properties that make it look like one. It is a concatenative stack-based language, so it's postfix syntax. It uses... it has like a ever-present stack as like a data structure that all of the functions operate on. So all of your inputs and outputs for a function come and go off the stack. Yeah. Okay. Just for the sake of argument, I'm gonna just put the standard board and height width on here for now. Use math. Use combinators. We're still getting errors. Yes. Now that's what I expected. Okay. Okay. So now I want to take a bunch of booleans and make them go away. So it's like a push down automaton in real life. Exactly. So now do I just like and a bunch of stuff? Do I just like hit it all with a bunch of ands? Is there an easy way to... I guess I like doing that feels ridiculous, right? Still getting errors. What? Why are you taking... Oh. There we go. Yeah, I mean that feels patently ridiculous, but and also it's the wrong way around. You recommend 2 and 2 and I love the name of this vocabulary, short circuit. If every quotation in the sequence oh my god. So I can get rid of 2 cleave. Annika, this is incredible. I mean, it's incredible. I mean, obviously, like, you know, I'm doing something relatively basic with the stack here. I've got a big pile of data. I'm just trying to do some things to it. Obviously, someone would immediately encounter that and build these very specific, well, what feel like very specific functions. Use the combinational circuit library. But like, there's just always one that does the precise thing to the stack that you want. Wait. Why is that false? Why is that false? True. 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 Oh. Wait. Yeah, I reversed everything else except that one. Let me just quickly check this logic. So we're checking if it's safe. That's why I reversed them. So we want it's safe if x is bigger than 0. It's safe if y is bigger than 0. I actually want bigger and equal then on these. That is just a thing. Perfect. It's safe if x is lower than the board width -1, lower than or equal then, and it's safe if board height. Yes. Thank you, Annika. Does that? Oh, is that the wrong way around? Nice. Okay. So, how we can do with board height and width? So what I actually want here is words that don't. So this is where I was talking about. I don't know if I want like a pipeline kind of thing, because I have multiple options here for like signatures, right? Like I either have. So I either need this game state to just be set as a variable, which is probably the easiest way to do it. Like so many of these handlers so many of these like functions I'm writing are going to need access to the original game state object, and so I'm probably just going to want to send it as a variable, or I pass it as a stack effect to all of them. So like every one of these has it as a stack effect. I don't know. It feels more correct to be passing it as a stack effect. It feels easier to set it as a variable. But I think I want to pass it as a stack effect. And so I'm going to want... but then, if I'm passing game state as a stack effect to everything, I don't even necessarily need to like... So like if I rewrote this... in terms of game state, right? So we do snake head, snake head, snake head, snake head. No, that's incorrect. That's incorrect. We would do snake head. There we go. That feels better. That feels a lot better. Because now it's easier for me to do... I guess there's a free and, isn't there? There we go. So like now I could do... That's why that worked. So we have game state coming in. So I can do one and then I can do snake head in all of these. But I also am getting the game state in here. So for these ones, I can do dupe. So dupe the game state, snake head. We end up with x game state xy. Which one am I doing here with? We drop the y, consume the x. So I drop and swap, and then do... No, I don't need to swap. Here I can use buy. So we drop and then do... Which way round does buy work? No, I don't buy. Yeah. I'd want to buy. Yeah, I don't buy. Yeah, so drop and swap, and then I replace this with board width. So game state comes in, two game states, consume one, XY. So game state XY, drop Y, swap, X game state. Board width from game state, it puts X on. So it puts the board width on. We then put 1 on, we minus those, and so we end up with two numbers. Okay, yeah, that works, I think. Okay, that's what I'm gonna call it. we can check for safe bounds. Again, I've achieved next to nothing today, but I feel so good about it. I feel so good about it. I love this language. Thank you, Annika, again for showing me some really cool tricks. Actually, I'm going to make a note. Let's make a quick. Let's make some quick notes here. So, grabs 2 items on stack, applies quotation array of quotes. And then where's this applies 2 quotes to 1 stack item. Cool. Yes, correct, VJ. Cool. Alrighty. Yeah, I think this makes a lot more sense doing it. Just pass the game state through with everything. Just give everything game state, and then this also answers my question. So I was asking, like, I was saying, do I want this to be like a pipeline situation? Like, do I need all of these to be returning game state? Because I was thinking just in terms of like, take something off the stack, do something to it, put stuff back off the stack. But now that I know about these combinators that can take one thing and hit it with a quotation, my actual like handle move can do all of this. Like, each of these can be a quotation, and then we're applying yeah, in fact, actually, the above array of quotes going to 1 and, right? So all of these like all of these bits are checking for safety. We're producing booleans, so we take a game state in, we do the 1 and trick to all of these, and then we know whether a move is safe. We know whether it's whether all the moves are safe. So we know which moves are safe, rather. We'll know which moves are safe from this, and then we can choose a move. Once we know which ones are safe, we can make our selection. Cool. Okay, now I'm ending. We went over time because I was having too much fun. Thank you, everyone. Thank you, Annika, again. Thank you, Hugh. Thank you, Brunoma. Thank you, VJ. Thank you, Being, who I know is not here still. Thank you for hanging out with me today. And next Coding Badly, actually, I believe Kevin will be back. So this might be the last time I'm doing Factor here on my own. I might have to take the Factor elsewhere. Yes, next Coding Badly will be November 3rd. Will be November 3rd. Kevin will be back. Kevin might want to continue doing Factor with me. We'll see. Otherwise, we might be doing something else. But otherwise, see you on November 3rd, which incidentally is also the day of some Fall League shenanigans. So the Fall League tournaments are right around the corner. There's a Snake Pit Live next Saturday. No. I don't know. It's coming up. Platinum quarterfinals. Yeah, they're coming up. All in November. So there we go. Thank you, chat. Thank you, Battlesnake Official. Platinum quarterfinals, November 2nd, November 3rd for the finals. So on November 3rd, we will be back with Coding Badly at the usual time, and then a couple of hours later will be the Platinum finals. So packed day on November 3rd. Clear your schedules. Lots of snaking to be had. Okay. See you later, everyone. Thank you so much. Catch you next time.